Alrighty, hello everyone, and welcome back to the stream. Um, so I've forgotten where I've placed my dry erase markers, which is an excellent way to start. There and alrighty, hello everyone, and welcome back to the stream. Okay, I had myself unmuted there for a second. Okay, now we're back to getting into it. So, last time on stream, we had a problem in chemical engineering that we were approaching, which was a typical mole balance question. And where we had left off, we had been working on a steady state unit to be able to describe like the pipes in our system. I've kind of refined the idea, and here's how I want to try and approach it for this session. So, the way I'm sort of thinking about it is when we have a system, we have a system that describes a series of interactions between units. So for the previous one, we had a pipe that led into a joining connection, leading into a condenser, leading into a split connection, which led out. Out of the condenser was the water outline, and then there was also a recycle stream. So I'm thinking for our steady state unit that we have described in the previous stream, that's going to need to be encapsulated in sort of a systems class. So what I'm sort of thinking is, we have a class called a system class, and this system encapsulates everything about our problem that we're looking at. So we have our inputs, our joining stream, our condenser, our outlet, our split stream, and our exit and recycle. All these different parts in here are units, are different objects within our class, but the overall system class describes the overall system. I'm not sure if I described that very well, but that's sort of my approach for this one. I realized I wasn't holding this high enough. My bad. Hopefully that's better. Okay, so now we can try to start approaching this. Also, the other thing I was thinking about currently with our setup, we have to provide a value to our steady state unit. However, with our problem, different units are defined with different values. And so we need to be able to accommodate that, and then also be able to get all of that and turn it into a system of equations that we can solve. So those are the three main sort of objectives of this stream. So back to the coding screen. So here's what we had from last time, our steady state unit and our inputs and outputs. So last time we were here, what we wanted to do was implement a way to have the species in a unit. So I'm not sure if we should go into the species because that will be important, or if we should try going to the steady state. I kind of want to continue with this and get it to be able to like hold the different species that we want it to before moving on, just so we're not like ping-ponging all about the place. So just like if you're not sure what's happening or need a little bit of a picker-upper, I'll go back to the dry erase board. So what I mean by species is that we're looking at a condenser problem. And so at our input, we have water and dry air. Those are our two species. We have an overall molar flow rate through this pipe of, say, 100 moles per hour. And we're going to say about 1.7% of that is water, and 100, or like, yeah, 100 minus 1.7% is the dry air. So the way we currently have it set up, we have a private float flow rate to describe the overall molar flow rate of our system. And we've got this hash map set up for our composition. A hash map, like I said, is basically just a way to hold a key and a value, two things together, and be able to access the value by knowing the key. So we'll always know the value, we'll always know the species in our pipe. It's just we won't know the value, so that's useful to us. I'm just also going to quickly open up W3 Schools. Not for their C# tutorial, because I'm not doing C#, but for Java. Remember, like, this is always a very useful tool if you just forget syntax real quick. Hash map. Yep, key value pairs. Excellent. So that's how you instantiate it. You basically say hash map the different data types, the name, and then you use the new keyword hash map, and basically that. So to add the items, you use put, and I guess that's how you get them to access an item. You say get with the keyword, and then that gives you the value, and then that's how you remove it. Excellent. Okay, that seems pretty straightforward. So the obvious thing that we're going to want to achieve here is that percentages always need to add up to 100. So for every species that we add, those species compositions need to add up to 100. So we have a linked list for that, and a hash map for the composition. No one in the chat to help me, so that's good. Let's just focus on adding species to our thing at the moment. So let's just say species and percentage. So we've already got that, a string and a float for the hash map. So let's create a method called public add public steady state. Oh, that's the constructor. I should probably leave that at the top. Public void add species. Do I want my methods to be yeah, I do. Add species. Add species, and we're going to want a string name for the species and a float percentage, not percentage composition. We're going to want to run an if statement to make sure that this value is not greater than 100. So if percent is greater than 100, I'm not sure if I want to have it as like decimal points, like 0 point something, or just percentages, so between 1 and 100. I think I'll go with that. So yeah, if percent is greater than 100, we're just going to have something go to the print line, because we're not going to get into error exception handling just yet. And just say system, not, okay. that actually works, okay. Percentage cannot exceed 100. Excellent. And then else, actually, let's make that a boolean, so that this needs to return a false. So this just tells us if our process has succeeded or not by making it a Boolean, which means that our method now has to return a true or false, and we can say that if this process has failed, we'll return a false, but if it succeeds, we'll make it true. So that is composition dot, and what's the proper syntax here? Put. It's put. And then we have name, and value is %. Excellent. We can now add species. Oh, yeah, we also have to return, not return output, return true. Excellent. We now have a method for adding species to a steady state unit. I accidentally have deleted it all. Okay, excellent. So now I guess we should just test that. We can go to our main method. Steady state unit is not happy because we've changed something here. Constructor int is defined. Steady state unit flow rate component % composition. That's right, I had that in the constructor already, you silly Billy. Do I want to put it in the constructor? Well, actually, I can just call this add species method now. I can just say add species component % composition. Booyah. Excellent, that works now. And that, I guess what we'll also want is we'll want to test this. Is it public? I think it's currently public, so we might just be able to access it in the main method. I'll make it public just to know. You typically don't want to do this. You typically want to have setters and getters. However, we're debugging, so we don't have to worry about that just yet. Setters and getters is where instead of directly accessing... Oh, I'm not on the coding screen. Oh, man. Streaming's hard. Okay, yeah, so I had this whole add species method here. And, I hope you were at least able to picture what was happening as I was describing it. I wanted to go along the whole way. So, yeah. We've made it that far. On to the main. So what I was saying about setters and getters. Typically, whenever we have a class variable or an instance variable, we don't want people in a outside class being able to access it directly. So they won't want you to be going into the main class and accessing steady state unit dot flow rate and saying this is mine now. Rather, instead, what they'd want you to do is have a method that gives you that value instead of accessing it directly. Because that way you can put conditions on what can be put in there and what can be taken out, and that just allows you to have a lot more control over your system. So steady state okay, I'm now thinking of implementing this, and I'm thinking, okay, so we have steady state unit pipe 1, and we're going to say that its composition is water. Yeah, string component and then composition, and then we'll just put 80%. However, because we only have one component, its automatic % composition is going to be 100%. We need to add more than one component before we can give it a comp percentage. So how are we going to do that then? I could go back to the dry erase board, and I can try not to forget how to go back to the coding screen. So what are all the different ways we can instantiate steady state unit or give it what it needs to understand its composition? So my immediate thought was we have a class called a steady state unit, and we have its flow rate. Can you guys see that well? Yeah, you can see it all right. We have its flow rate, and then we define a species. So we'll just say species 1. We just add that on, and that automatically becomes 100%. And then we say, okay, we need to add another species. And so we'll say, okay, we'll add species 2. And its percent composition is going to be like 20 or something. And then what we do is we just take that off of species 1. It becomes 100 minus 20 equals 80. And then we'll say, okay, we want species 3. Species 3 is going to take up 30% of that flow rate. And so it's going to be taken off of species 1 again, minus 30. However, this kind of, I don't like this really. Oh yeah, equals 50. There we go. I don't really like this method because it doesn't really give us that much control. I'd kind of like a method where, like, at the start, you define all of the species and all the concentrations. So like there's one giant form where you're like, okay, species 1 is this, it's 20, species 2 is 30, and species 4 is 50. However, at the same time, having this sort of requirement means that we don't have the ability to just not know a composition, which is the whole point of this program. It's to solve for that unknown. So we need to be able to have a way to just add the species and maybe not even know the percent composition and come back to that later. So it might be a good idea the first way, because in that way we can say species 1 has a composition of 30, species 2 has a composition of 15, and then species 3 has a composition of I don't know. It's just a big question mark. And then we can leave it that way, and whenever we're coming back to making our system of equations to solve it, we'll know that we don't know what that is, and so then we can come back to it. Or we can just add up and say, okay, so this is, everything here has to add up to 100. So we can make a system of equations there, but like, I digress. So my microphone's a bit flimsy. That's why. That's better. Okay. So once we've instantiated a pipe, we probably don't want to actually define its species from the start. I don't know if I want to do that. Yeah, probably not. Yeah. Yeah, so we're going to remove that from the constructor then, and just have it as a public method so that it's added. And so in this way, we know if we know the species. So we can know the flow rate. Whenever it's instantiated, it has to have the flow rate, but it doesn't have to have a species. So I think we're good on that part. So there's that, and now we can just say something like pipe1 dot add species, or add species, and we'll say water. No, not watch service. Water has a percent of like 98%, and pipe1 dot add species, not add input, add species, and we'll have that dry air is equal to 2%. I can go back, and then we'll want to return the output 1 dot stop it, not get class, dot composition dot get object key, and we'll want to know water. Okay, don't need two of those. So that should be working. We can run. Yes, allow access. Excellent. So we're getting the proper composition being returned. That's great. So that works. And now I'm just going to check and see what happens if we don't know the percent composition for dry air. Instead, we'll just put null. So it doesn't like that. It's not applicable for argument string null. Okay. So that's what I sort of wanted to do in the case that we didn't know its percent composition. We just put pass null. So, how can we adjust that? So what it's currently saying is that this method is not applicable for this argument. We can't pass a string and a null because we need to pass a string and a float. So I'm not sure what to actually do in that situation, but we can try and figure it out. Let's try some polymorphism here. And we'll just say this instead we pass a null. Null pointer exception. Yeah, no, I didn't think so. So we can't do that because we can't just have it ask for a null thing. That's typically an at runtime thing we want to worry about. Like we access something while we're running the program and it's like, oh, there's nothing there, it's null, and then we have a null pointer exception. But it doesn't really work when we have a method. Is there a way to just have it where it just doesn't instantiate the percent composition part? So what I mean by that is if it's not instantiated, whenever we call it, we get a null pointer exception. I'm not sure if, like, at the time that it's instantiated, like the hash map, like every time we add it, it needs to be instantiated. I would think so, honestly, though. So maybe back to the drawing board on that. I don't want to put it as 0. I guess it could be 0. Because if we don't know what the percent composition is, we know it can't be 0 because we know it's there. We just don't know what it is. So 0 could be a good number, actually. So yeah, we'll just have it as 0. 0 is when we signify that we don't know what the composition is. Okay. So there's that. Dry water and dry air. Excellent. And now I think it might be a good idea to get on to the system, like the process system, like a class. So we're going to create a new class called process system .py. Oh, it's Java, not Python, you silly Billy. Rename that. Thought I was in Python for a second. I don't know what that was. Process system Java. public class process system. There we go. That's how you spell it correctly. So what we're going to want to do is we're going to want to be able to have a process system, and then we're going to want to add steady state units to that process system and be able to define the connectivity between those process systems. And the connectivity between those process systems, and say, okay, so if this process system is feeding to this process system, it's going to be getting these components, but we don't know its composition. So yeah, I guess we can start on that. I'm not sure we need a constructor yet. I guess we could. Public process system. And we can say that whenever a process system is instantialized, whenever a process system is instantialized, we have at least one steady state unit that's always in the system. So that way we can always understand it. So for that, we're going to need some sort of instance variables to say, okay, we have steady state units in here. So I think we're going to use a linked list for that. Linked list of type steady state unit. And we're going to call this our process chain. It's equal to new linked list. Steady state unit, excellent. And we'll say that when we have instantiated process system, that we're going to add a steady state unit to our process chain, and that's going to be our starting steady state unit. So process chain dot add I need to instantiate it first. Steady state unit start node is equal to new steady state unit. Oh, that's right, I need a flow rate, so I should really change that so that it can just have a not starting flow to we just don't know. I'll just put it at 100 right now. So we'll have that in our code. I'll make that as a comment. Edit start node in the case we don't know the flow rate. Other thing I'm thinking about too is in this case, like in the future downstream case where we're going to have more than 2 starting points feeding into our system. And in that case, we're going to have more than 1 start node. So, but this is just to ensure that everything is connected and we have one coherent system. So we're going to limit this to be one coherent system by saying that, okay, anything in this system can only be added in by adding on to an existing node or an existing steady state unit. I don't know where my FN is, and I'm so lost. And so process chain.add start node. Excellent. So now when we start up our system and we have a process system, we have a starting node. and that starting node has a flow rate. Now we need to be able to define the composition within the process system. This is the one thing that's like kind of like daunting about this. It's like, oh wait, I'm now coming up with problems that I have to solve on the fly in order to keep a stream entertaining. It's like, okay, well, I guess the one thing that does is that it makes sure that I don't think on one thing too much. It's like, okay, try something, see if it works. If it doesn't, try something new. And if it does work, what's the problems or limitations with your implementation, and how can you fix it for the next time around? So there's that, yeah. Because like I remember I had attempted a project at this before, and my main thing is I would go into another method, my main, to set up my steady state unit and all that good stuff. And it's like, oh, for each and every individual unit, I want to have control over that without having to access it through the steady state unit. And I'm just, or like through the process system. And so I'm like trying to figure out how I might address that problem with my like thing going forward. But for now, we'll just stick with this. The next thing we're going to want to do is we're going to want to be able to add a process to our system. So public, yeah, public void add process. And I guess we might want to have a float flow rate. No, because we won't know the flow rate every point. So we're going to need to change that in the steady state unit to not have a flow rate. Because at any point in our system, we just want to be able to describe connectivity. The flow rate and the composition are two things that could be unknown at any point at any time. And that's what we're trying to create here. And a solver that, using other information from the system, is able to calculate those unknowns, whether it be the flow rate or composition. So I'm going to go back and change that in steady state unit so that we don't actually have to pass a flow rate. And so that means that's no longer needed, that's no longer needed, and actually this constructor is just no longer needed. Okay, process steady state unit. Yeah, okay, that can just die. Oh wait, that's right. I need that. Add process. And so I think I'm going to put a name. Yes, the one thing we should have for our steady state unit is a name. It shouldn't have a flow rate, it should have a name. Public steady state unit string name. And we'll have a private string. And we'll say this dot name is equal to name. Excellent. So that works. And so now we have to give this a name. And so the name of our instance is start node, but it's also going to have the name start node. Yeah, I think I like this. Mm-hmm. Okay, yep. So we're going to go to add process. We're going to have it say string name. So basically what this is going to do is we're going to say string name, and then also string connection. Oh man. The more you think about it, the more problems come. So the thing I'm thinking about here is, I'll bring up the dry erase board. We have a situation where we have our start node. We'll just name that SN. And then we want to create a new node. So we'll just put that right here. We'll give it new node. And so when we create this new node, we have to give it a name. So we'll call it new node. But then we also have to describe what it's being connected to. So we need to pass the name of the start node. And then we need to describe the connection between the two. The start node needs to know that it's being connected to the new node, and the new node needs to know that it's being connected to the start node. And another thing, we need to know the direction of this connection. Is new node upstream or downstream of start node? It's obviously downstream, but that's obvious to us. It's not obvious to the computer. We have to tell it that. So we need you to explicitly say it's downstream from start node. So that's the problem I'm facing right here. Because that was the whole idea behind giving the steady state units a name. It's so that when we're now going into describing the connectivity, instead of having to index them by going into the linked list, we can say, okay, we'll give you this name. You're then going to search through this linked list, give us that steady state back, and then we're going to attach our connection to that. So I could have two different methods, I'm sort of thinking. We could have two different methods where the method only takes the name of what you are, like the new node you're creating, and then the node you're connecting to. But the two different nodes are all dependent on whether it's upstream or downstream. So you can have a method called add upstream node. Can you see that good? Yeah, kinda. And add downstream node. I'm not sure how I like this, creating two different methods as opposed to just adding another parameter. However, I feel it might be more intuitive to just any regular person who might use it, and it might make reading the code more clear. So we'll rename that add upstream node, and we'll say new node name. And then we'll have a string connecting node name. That's still quite ambiguous. Maybe just old node name. Or existing node name. And so what we will do is we will instantiate a new steady state unit. We'll go steady state unit new node. is equal to new, steady state unit, and we'll pass through new node name. And then what we will do is we will go through our linked list to find the existing node name. Actually, we'll also make this a bool in similar vein to the other one. So that, yeah, boolean, not a, is it just regular bool works? No, it needs to be boolean. This isn't C#, you nerd. Okay. Excellent. So now we can say, oh, brain's farting out hard right now. So my idea here is, now that we have the new node name and we've instantiated a new node, we now need to look through our process chain, which is going to contain all of our steady state units, and see if any of them have the name existing node name. And if we do, we're going to add new node to their downstream or output linked list. So yeah, here we've got linked list outputs. We're going to add this new node to this steady state unit's output list. So we need to then check if linked list contains that. So we can do this two different ways. We can say if, of course it doesn't like doing it all for me anymore because I'm using VS Code and not Visual Studio. Process chain dot, I'm sure they've got a contains function. Yeah, contains. And we'll say, oh wait, no. So contains doesn't really work because it looks for an object. So we would need to have the actual reference to the start node. That's stat node. I've screwed it up somehow. There we go. And that will be a pain because we need to see, because we need to check its name. We need to give it a name and then like check if everything in this process chain has that name. So I think we'll have to use a for loop. For int I equals 0, I is less than process chain dot length, or what is it, size, there we go, beauty, I plus plus. What we're going to want to do is we're going to want to check if each steady state unit in this linked list, we're going to want to check its name, and we're going to want to see if it's equal to our existing node name. So process chain I forget how to index a linked list because it's different than an array. Okay. An array list might be more useful than a linked list, because a linked list is for manipulating data, whereas we're only really looking to store and access data. Array list has a regular array inside it, and when an element is added, it is placed into the array. If the array is not big enough, a new larger array is created to replace the old one, and the old one is removed. Okay, fairly simple. Yeah, resizable array, which can be found in java.util package, Difference between a built-in array and array list is that the size of an array cannot be modified. If you want to add or remove elements to or from, you have to create a new one, while elements can be added or removed from array list whenever you want. Syntax is also slightly different. So that's the thing, it's that I need to use the indexing method here. Okay, yeah, because linked list doesn't really have easy indexing. Yep. Okie dokie. So we're going to change these to array lists or like right here, we can change that to an array list. Yeah, now I have to use different stuff, different keywords. So it's process chain dot. Oh wait, no, that's also going to be changed over there, array list. Don't need to capitalize it. Array list, array list. You're the same. Start working, please. I'll be resolved to a type. I need to, oh, that's right. I need to add it in here. No, stop it. Excellent. Add start node. Yes. Yes. Dot get index I dot name. I can't access the name because I made it a private integer. So we'll just make it public for now. However, I'll put a comment saying that we need to create a getter. Yeah, so dot name. Yep. Or at least we need this in an if statement. If is equal to existing node name, then what I want you to do is I want you to, at the end of it, return true. But then I want you to take process chain dot get I, and I want you to dot composition dot values. No, composition. Silly Billy. Dot outputs. Add upstream node. Yeah, outputs dot add new node. There we go. And then return true, and if this all fails, return false. Excellent. Oh, so now we should probably test to make sure that this is actually working, which means that we actually have to figure out how this actually works. Coding is fun. I'm just going to put more spaces to make it more readable. Save. So yeah, my main is dying a terrible death at the moment. So we're just going to delete all of that. Process system. So we're going to want to create a system. So we'll call it process system, and we'll call this condenser, or my condenser. And we'll have that equal to new process system. Excellent. And so this process system should have our start node. As soon as we start it up, it should have the start node, and that'll be added to the process chain. And so we're going to want to see if we can add a stream node. Add upstream node. Okay. Main condenser. Yep. Okay. So we're creating a condenser system, and we have our add upstream node, and we're going to say my condenser dot add upstream node, And we're going to want to add the upstream node to the start node. And our, oh wait, no, that's our new node name. So we're going to call our new node name N1. And we're going to call our existing node name start node. Just make sure start node is the name. Yes, start node. Excellent. Steady state unit. Start node. And then we can just actually just print this because my condenser, yeah, upstream node is, oh, brain screwy. Is a bool. So we can just ask it to return that and see if this thing actually succeeded. So system dot out dot println, and then we'll just copy or cut paste. Bracket? What? Syntax error. It says insert one of those to complete, but yeah, no, that's not a new one. Alright, well, what's happening here? Oh, is that a lowercase? No. System dot out. System dot out dot println. There we go. So it needs something to print now, which we can probably fit in there. Oh no. Yep, that works now, mysteriously. Why is that? Oh, I don't have the proper curly brackets. More curly brackets? No. Insert curly bracket to complete method body. This isn't a method though. Yeah, that's there. That's what? I must have a random curly bracket somewhere, but I don't know where. I'm so confused. The class body is being completed. What do you mean? I don't need a watch service. Okay. I'm going to just completely rewrite main. Main. There we go. No. Something has gone terribly wrong. is this? What is this error? Main. We have a public class main. Inside we have a public static void main method. I'm so confused. I have no idea what's going wrong here. It's working fine now. Jesus. He works in mysterious ways. Okay, now save, run. It's returning true. Therefore, it's working. I guess the next thing to do would be to check if it's in the downstream, but honestly, I think that's it for tonight. I am quite tired. And I've been making mistakes too. So, I hope you enjoyed that. I hope you learned something. I hope you had some fun. Streaming's been a bit inconsistent, but I take it where I can get it. Until next time, I'll see you guys later. Thank you. Bye.